Okay, for this video, I'm just going to go through this final review packet here. Just going to go in order, so feel free to skip to whatever question you want, forwards or backwards, and let's get started. Okay, so all the way back to the beginning of the class here. Name 5 planes shown in this picture. So to name a plane, we need to use at least 3 points and have them be non-collinear. So this plane right here would be plane, and you need the words plane, so plane DCE in any order. Now, the reason you need the word plane is this could have been a triangle DCE. We could have been talking about angle DCE. So you need the words plane. Okay, we also have plane, and I'm going to erase that. And now we're talking about this plane here. So just any of those 3 points. So I'm going to call them ABC, but any of ABCD, any of the 3 points there. Okay, and then now I'm going to talk about this triangle plane in back here. So that's ABF in any order. So plane ABF. Those were the only 3 letters we have for that one, but it could have been in a different order. Okay, and then for this one, we have BCEF. So I'm going to call it plane BCE, but you could have thrown in the F there in any, so BCF, FCE, whatever combination there, just as long as the 3 points aren't on the same line. And then finally, the last plane shown here is this plane, right? So you could call this one plane fancy letter P. Ooh, that's a gorgeous P. Or you could have called it any of the 4 points here on this bottom, because it's also the bottom of this solid here. So you could have labeled it by like ADE or FAD or anything like that. So any of those names for that bottom plane. Okay, next one, name a line that is coplanar with AD and AB. So AB and AD determine a plane. So AB is this line here, AD is this line here. So there's only one plane that goes through 3 non-collinear points. So let's take point A, point B, and point D. That determines a plane. The plane those 3 points determine is this. So those 2 lines determine a plane. And then it says name a line that's coplanar with those. So any line on that plane. So for example, we could have said AC, that's one line. We could have said BC, that's one line. We could have said CD, that's another line. Or we could have just connected B and D, so BD. And then the third one, name the intersection of planes P and the plane that contains AB. Okay, so ABE would be a diagonal plane connecting these. So it would be a plane slicing diagonal from line AB straight to E. Okay, so name the intersection of plane P and the plane that contains ABE. Okay, so you have this plane diagonally slicing from AB, like that's its direction, and then which direction is, or I mean, that's where it goes through, and then its direction is it's pointing through E. Well, where does it intersect plane P? Well, it gives it to you, right? I mean, it intersects plane P at A, which is on both planes, and E, which is on both planes, and the entire line that goes through there. So you have 2 planes intersecting. Just to draw it like this, you have 2 planes intersecting at a line here. Whoa, that was a terrible drawing of 2 planes intersecting. It would look like this. I'm going to start with the other one. Let's try that again, okay? So 2 planes intersecting. So let's say they intersect here. It looks like this, right? And then you would just use a different color to show which ones are dashed. So like this one would be behind, and this one would be behind. So that would be the intersection of 2 planes as a line. And you know the 2 places where they intersect are A and E because those are on it. So I'm going to just erase all this because that crazy drawing. And so the intersection of those is exactly line AE. Okay, let's scroll down. So find the length of AB. So AB is going to, here's 6, here's 7. So this is 6.5. This is 6.25, 6.75, or 6 3/4. Here's 7.25. and 7.5. So we just subtract. We go, well, this ends at 7.5. This is at 6 1/4. So that's 1.25 or 1 1/4. Find the precision. So precision is really cool. We put an X here. That's not something we talked about in this course. But precision is simply saying, like, significant figures in science and stuff. When you say 6.351, what you're essentially saying is, I am super certain about these digits. And then the last one's a guess. So for example, if I was using this ruler here, I would say, well, I know that my precision is, like, if I have a dot here, I know it's between 6 and between 6.25, but I'm guessing where in between. Or an easier time to see precision is, for example, let's say, easier one is if we had all these markers, so like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and they were all equally spaced. And then if we had a dot right here, you go, oh, well, I know that's between 6.4 and 6.5. And so I would write a number like this is 6.43. And that would be me saying I am certain it's between 6.4 and 6.5, but I'm guessing this last digit. That's what precision is. It's saying how certain are we of it, not is it accurate. Like another analogy for precision is if I'm shooting a soccer ball at a goal and every single shot lands over here in a tight little group. So every time I shoot, I'm aiming at the exact same spot. That's very precise, but it's not accurate. Accurate would be, did I make it in the goal? I did not. Not accurate. But precise means all of my shots are close together. That's what precision means. So precision meaning how close are we or how certain are we of that number? And more precision would just mean more decimal places. Okay, anyways, find two possible lengths for CD if CD and E are collinear. And so there's really only possibilities, right? If C, D, E are collinear, for example, let's say, all right, so here's C and D. If E is collinear with these, there's only three possibilities, right? E is over here, or E is, I guess I should do that in a different color since it's like extra possibilities. But the only possibilities are E is here, E is here, and E is here. We're explicitly discounting the one where E and D are the same point with different names. Whenever we're in geometry and we say we have 3 points, we're excluding the possibility that they're actually the same. We're saying we do have 3 separate points. That's the thing. All right, so anyways, it says CE is 15.8 centimeters and DE is 3.5. So let's see. So we've got C and we've got D, and we're saying the distance from to E is 15.5. So 15.8. Oh, don't have much room here. And then we have, this is 3.5 centimeters, okay? So find two possible lengths for CD where that is true. All right, so we don't know how far apart these are. So I'm going to draw two different possibilities here. Let me erase both of these just to kind of highlight this. Okay, so what we do know, starting from what we know, is here's C, and we go to E is 15.8. All right, and now DE is 3.5. So given that, the only possibility, if this is a true length, is either we have DE swinging to the left or swinging to the right. So we add it on 3.5 to D, or we subtract 3.5 to get to D. So we either go 15.8 minus 3.5, that's the distance, or we go 15.8 plus 3.5, that's the difference. So over here, the two possibilities are 15.8 plus 3.5, which is 18, that's 19.3, or it's 15.8 minus 3.5, which is 12.3. And those are the only possibilities. Whoop, I said 12.3 and I wrote 12.5. That was silly. Okay, find the length of RS if S is between. So S is between R and T, right? So visually that means we've got a segment RT and S is between them, okay? But mathematically what that means is RS plus ST is exactly equal to RT, okay? And that's because the shortest distance between two lines is a straight line. And so if we went 3 and then we went 4, we went a total of 7, right? If we went any other journey, then we would go like this, I don't know, like 3.1, and 4.1, something more, right, to go a total length of 7, because we went out of our way. That's when a triangle is formed. If this is a greater than, that's actually the triangle inequality to say, yes, a triangle is formed. But if it's exactly equal, that means we have a segment. That means that S is between. That even is the segment addition postulate if we know we're given a segment. But anyways, lots of different ways to look at this. All right, so let's write it out. So RS is 1/3 the length of RT. Okay, that's good. RS is equal to that. ST is equal to that. Okay, so we can just substitute this in. RS into our equation. Why did I write +3? I'm at -3. That's our RS in our equation. Plus, and ST is 2x plus 6. And then it's saying RS is 1/3 of the total. So how could we use that? So we know that this adds up to a total of, so I'm just gonna arithmetically, because we know this, so we know that RT is gonna be 5x plus 3. Okay, we haven't done anything yet. So this is what RT is in terms of just using this fact and these two segments, so they add up to 5x plus 3. But then it also says the second fact is RS is 1/3 the length of RT. So in other words, our second equation is 3x minus 3, okay, that's RS, is 1/3 the length of RT. And then we just solve. Okay, so algebraically, I'm going to do it over here on the left because we don't have a lot of room. Okay, or actually, do we have a little room up top? I'll do a little erasing here. Okay, so I have 3x minus 3. Actually, I'm going to multiply by 3 on both sides, and that way it'll get rid of the 1/3. So I have 9x minus 9 equals 5x plus 3, just multiplying by 3. Then subtracting by 5x, adding 9 on both sides, I get 4x equals 12, so x equals 3. And what is it asking for in the question? It's saying find the length of RS. So we go back and we plug in 3, and for all of our values here, we get this is 9 minus 3, so this was 6, RS was 6. And then we plug it in over here, and we get that 6 plus 6. This was 12, and so this was 18, 18. And so yeah, was RS 1/3 of 18? Yes, 6 is 1/3 of 18. Is 6 plus 12 equal 18? Yes. So that all worked out, and it said in the end, find the length of RS. So we know RS was 6 long. Okay, cool question. All right, so let's go to this one. Find Y if AC is, it's okay. What are we really given here? We're given an AC, a CB, and an AB, and point C lies between these. Oh, so that means we've got a segment where we have an A and a B and a C in between. So we know that AC plus CB, so part of the journey plus the rest of the, what did I just write? Plus the rest of the journey equals the whole journey. That's the very definition of betweenness, or being collinear. All right, so now we can just add it up. So AC is 3y plus 5. And then we add that to CB, so that's 4y minus 1. And then that equals AB, which is 9y minus 12. So we can just go ahead and 7y plus 4 equals 9y minus 12. We subtract the 7y from both sides, so that's gone. We add the 12 to both sides, so that's gone. So we end up with 2y on the right equals 16 on the left, so y is 8. And this one just said find y if that is, okay? So y equals 8. I could always go back and plug that in just to double check. So that would be 24 plus, I'll do it in a different color. Let's do it in purple again. So this is 24 plus 5, so that's 29. And then the other one would be 32 minus 1, so that's 31. So if you add those together, we get 60. So hopefully this works out to be 60. So we get 72 minus 12 is 60. Good, okay, it all worked out. All right, so fine. I'm just showing you how you could double check your work, which A is a really good habit, and B, if you're on a final exam and you care about your grade, it's a good thing to double check as long as you have time. All right, for question 9, I was just taking a nice sip of coffee. Okay, for questions 9 to 11, use the coordinate grid at right. Find the distance between A and B. Well, you could use the distance formula, but really all the distance formula is the Pythagorean theorem. So this is a right triangle here because the x-axis and y-axis are perpendicular. And so this is up 2 and right 1, 2, 3, 4. And so really all it's saying is use the Pythagorean theorem with lengths 2 and 4. So that's 2 squared plus 4 squared equals c squared. That's 4 plus 16 equals c squared. That's 20 equals c squared. So c equals root 20. And you could leave it like that. So the distance is root 20. Okay, or you could punch it into a calculator and get it's around 4 point something, right? It's between square root of 16, which is 4, and between square root of 25, which is 5. So it's 4 point something. Let's just say 4.5, okay? But we could also simplify it. And when you get to chapter 7 next semester, that's what we're going to be doing. So I'm going to do that really quick. So I could rewrite this as square root of 4 times square root of 5, and the square root of 4 is 2. So that's 2 root 5. So you could write this as 2 root 5, or you could do wavy equals, it's approximately equal to, and then punch it into a calculator. Now I'm writing 4.5, but I didn't actually use a calculator, so that's probably off by a little. All right, find 2 possible coordinates of a point D on line containing AB. All right, so I'm going to erase this. So line containing AB, there's only one line that contains A and B. It's this line. Okay, so that AD is 1/4 of AB. Oh, wow. So there's 2 possible coordinates. So it's saying I want to go 1/4 of the way from A to B, or 1/4 of the way from B to A, right? So basically I'm going to chop this in half twice. Now, how would you do that? Well, we know how to find the midpoint, right? What's the midpoint? The midpoint's literally just the average. It's saying instead of going up 2 and over 4, instead you do half of that. So if I zoom in here and use a darker color, because that didn't show up very well, then what we get, oh, that's not a darker color. Let's use a pink here. Instead of going up 2, I'll go up half of that 1. Then I'll go over 2. That's half the journey. And then I go up the rest 1 and over 2. Now those are congruent triangles, right? I know I went halfway up and halfway over. So both of those are 1, 2 right triangles. So by SAS, they're the same triangles. So this distance is the same. So that's the idea of the midpoint. Just go halfway up and halfway over. So we know our midpoint, without any crazy calculations, is this dot right here, right? Or if this is 0, 0, then that's -1, comma, up 0. That's her midpoint. Now the question is, we want 1/4 of the way. So that's halfway. Well, we just do the midpoint a second time. Okay, so right here, all you do is say, well, I went up 1 and over 2. So let's go up a half and over 1, right? Up 1/2, over 1, up 1/2, over 1. That's halfway, right? So the point here is -1. No, sorry, I went back 1, back 2. So that's -2, comma, and then down -0.5. Okay, so that's one way to do it, just reasoning, and we could do that for the other point. But instead, let's actually use the midpoint formula twice. I mean, that's the reason we have a midpoint formula. So I'm going to write the points. So this point is back 1, 2, 3, -1. So this is -3, -1. And B is 1, 1. Oh, those are nice numbers. Okay, so first, midpoint of those is, we add up the x's, -3 plus 1 over 2. And then we add up the y's. So -1 plus 1 over 2. So the midpoint of AB is equal to, this on the left is -2 over 2. This on the right is 0 over 2. So that's -1 comma 0, which is just what we got, right? That's nice. That was our midpoint too. All right, so now the 2 possibilities are, we do the midpoint of that and A, right? That's 1/4 over from A. Or we do the midpoint of that and B. That's 1/4 over from B, right? So that's on the line so that AD, oh, I'm sorry, I misread the question a little bit. Whew. So this was all correct, except it's saying go from A is 1/4 the length of AB. So from A we'll go 1/4 this way. That's 1 point. But then we'll do 1/4 this way. I'm sorry, I started at B. So yeah, we got 2 points, one here and one over here. Okay, so let's find the first one. All right, so the first one is the midpoint of A and that midpoint. So the new midpoint of A, and let's call this point M, the midpoint. So midpoint of AM. All right, so that's just the average of the midpoint and point A, which is -3, -1. All right, so we add up the x's. So -3 plus -1 over 2. We add up the y's, so that's -1 plus 0 over 2. And so we get -4 over 2, comma, -1 over 2. Or in other words, -2, comma, -1/2. Perfect. Okay, so that's 1 point, right? But how are we going to do the exact same thing to go backwards? This is where you do use the conceptual logic here. So we say, okay, from A, how did we go that distance? So we were at, let me switch to a new color just for fun here. Okay, let's go blue. So if we're at A and we go from -3, -1, that's this point, to -2, so -2, -1/2, that's this point. What did we do? How did we get there? Because we want to go that same distance, but in the other direction. So we went up 1/2, and we went over 1. So let's just go down 1/2 and back 1, and here's our other point. So if we went back 1, we're now at -4. And if we went down 1/2, instead of being at -1/2, then -1, we're at -1/2. That's it. So here's 1 point. Here's another point. Cool problem. Really makes you like conceptually use stuff. So let's put that in there. And let's put this in there. All right. And then let's look at find two values of y for C located at 1, y and AC is 5. So it's saying we've got this point and point A, which is -1, 2, 3, -1. So we've got these 2 points, and it's saying the distance from AC to 5. Well, that's just the distance formula. So we could Pythagorean Theorem it, or let's just use the distance formula. So distance is square root of the difference in the y's plus the difference in the x's squared. So that is 5 is the total distance, is equal to the square root of, let's subtract the y's, so y minus -1 squared, plus, and then 1 minus -3 squared. So I'm going to keep that going over here. So 5 equals square root of y plus 1 squared plus, and then 1 minus -3 is 1 plus, so that's plus 4 squared. Okay, so what I'm going to do is I'm going to square both sides of this equation. So I get 25 equals y plus 1 squared, and the 4 squared I'm just going to write as 16. All right, so now let's subtract, and we get -16 minus 16. We get y plus 1 squared equals 9. Now I could square, or I could multiply this out, get a quadratic, so we get y squared plus 2y plus 1 equals 9. And the way you solve a quadratic is move it all to one side. We get y squared plus 2y minus 8 is equal to 0. We factor it and go, oh shoot, what multiplies to make -8 and adds to get +2? We could go, oh, that's y plus 4 times y minus 2. And then we could say, well, if two things multiply to make 0, then 1 is 0, y plus 4 is equal to 0, or y minus 2 is equal to 0. So then y is -4 or y is 2. So now we could do it like a quadratic, and I kind of rushed through that. Quadratics are good. But I like the more elegant approach here, where instead you just say, well, if a number squared is equal to 9, let's just square root both sides. Remembering when you square root, you have to manually put in a plus or minus because there's two possible solutions. That thing in the parentheses, the y plus 1, because the square root of squared, those cancel out. Those are inverse operations. So y plus 1 is equal to plus or minus 3. So really that's just two separate equations. Either y plus 1 is equal to 3, or y plus 1 is equal to -3. So then we minus 1, we get y is equal to 2. Or we subtract 1, and we get y is equal to -4. So either you found that more elegant shortcut, or you manually, multiplied it out, right? That's FOIL. So the next step would have been y plus 1 times y plus 1, and you do every combination to get this. Then our strategy, whenever we have a quadratic, is move everything to one side, equal to 0, then factor it, and then once you've done the factoring, then either the left parentheses or the right parentheses must be 0. Because the only two numbers that multiply to make 0 is 0 times something. So that's cool. Cool problem, you guys. Gosh, like just reviewing everything here. Algebra 1, geometry, and this is still just from chapter 1. Okay, find y if S is the midpoint. Oh, so it's just a midpoint formula. And T is the midpoint. Oh, this is a cool picture. So let's look at this. So what we have here is we have S is the midpoint of RT. So here's RT. And then S is the midpoint. So these are congruent. Okay, S is the midpoint of RT. But also T is the midpoint of RU. So what that means is over here, RU, you have two of these. So if this is like X and X, this is a 2X length because T is the midpoint of R and U. That's really cool. All right, so anyways, it says RS is, and I'm going to use a different color here to write this. And I'll erase what I wrote. All right, so RS is 6x plus 5. ST is 8x minus 1. And TU is 11y plus 13. Well, since S is the midpoint of RT, that means these two are congruent. So right away I can go off to the side, and there's not a lot of room here, but that's okay. I'll do it in this tiny gap over here. We know 6x plus 5 equals 8x minus 1. Okay, and then we just solve. So minus 6x minus 6x. We go plus 1 plus 1. So we get 2x equals 6. We divide, we get x equals 3. I'm going to plug it in just so I know. So that's what, 18 plus 5. So this is a 23. And then over here, plugging in 3, we get 24 minus 1. So that's a 23. Good, that checked out. Okay, whew, that worked. And then the next one says find y. Well, we already have now, because I already plugged in the values, we know that this is a total length of 46. And we know that T is the midpoint of RU, so that means this is 46. And so now all we do is we go back and we say, okay, well, that means, let's do it on the right over here now. 11y plus 13 equals 46. Subtracting, we get 11y is 33, so y is 3. Oh, look at that. That's funny. And then we plug it back in just to double check. 33 plus 13 is 46. So it all checked out. So here it was just saying find y. If yada, yada, yada. Oh, it only wanted y. Okay, y equals 3. Find all values of x that will make angle A obtuse, given that, okay, so it's saying we have this. Well, if we want A to be obtuse, what is the very definition of obtuse? That means the measure of angle A is bigger than 90 degrees. And I mean, technically, we would say measure of angle A is less than 180 degrees, like personally, because if it's 180, it's a straight angle. If it's bigger than that, we don't call it obtuse anymore. I don't know that we have a term for saying it's bigger than 180 degrees. That's a good question. But let's just go with the first for now. So 12x minus 6 is bigger than 90 degrees. Okay, now we just add 6. We get 12x is bigger than 96. Dividing by 12, we get x must be bigger than 8. Okay, now if we were to go a little further and say, well, it also has to be less than 180, because in chapter 1, that's how we defined an angle. Let's go ahead and solve that too. So 12x minus 6 is less than 180. So 12x is less than 186. So x is less than whatever 180 over 12 is. So let's just divide. So dividing both by 2, we get 90 over 6. Oh, that's 15. So that means here x has to at least be bigger than 8. But I think also it's less than 15. And notice I didn't say equal, because if it was equal to 90, we would get x equals 8. So we want it to be obtuse, not right. So it's not greater than or equal to. It's just greater than 8. Okay, so find measure of angle RST if ST bisects RSU. So that means this angle and this angle are the same. And SU bisects TSV. Oh, well, that means this angle equals this angle. So by transitive property, all three angles are equal to one another. Okay, so what do we want to set up first? Now, we've got x's and y's here. So if we set that equal to here, we're going to have x's and y's in that equation, okay? Well, what if we set it equal to here? Oh, x's and y's in the equation. Well, what if we set these two equal x's and y's in the equation? So when we have x's and y's in one equation, we have infinitely many solutions. So I can tell already, unless we can do some really clever like precision trimming, we're going to have a system of equations here. So let's just do a system of equations. We don't need to run away from it. So one equation we have is x plus 2y minus 1 equals 6x minus 9. Okay, that's one equation we have. And then the other equation we have is the same thing, x plus 2y minus 1, except equals the other one. So 2y plus 5. Okay, now you could have used these two are equal as one of the equations. We actually have three equations here. Anytime you have two variables, you really only need two equations because we're essentially saying where do two lines intersect, right? Because a line is just a relationship between x and y, right? Like x plus y equals 5. All right, so let's go ahead and solve this then. I'm going to delete that. So over here, we need to just clean this up. So I like writing it in standard form. So I'm going to move all the x's and the y's to the left. So we're going to subtract the 6x from both sides. We're going to add the 1 to both sides. So I get, some people like substitution. I don't want to do substitution. I like doing it in standard form. So my system of equations here, the top one is going to be this cancels and this cancels, and we get negative 5x plus 2y equals negative 8. Okay, and over here, I'm going to move the two y's. Oh my gosh, look at this. Our second equation, when we moved it over, and we add 1 to both sides, okay? So we end up getting x plus no y's equals 6. What the heck? X just equals 6. This was the easiest system of equations ever. So if we have x equals 6, we plug it in to our other equation, right? So x equals 6 came from this equation. So we don't plug it back into itself. We plug it into this one. Okay, so now we have negative 5. We just plug in the 6 plus 2y equals negative 8. Okay, so that's negative 30 plus 2y equals negative 8. We add the 30, we add the 30. We get 2y equals 22, so y is 11. And then we plug it in just to see if it works. Okay, so on the bottom one, that's 22 plus 5, that's 27 degrees. So they should all be 27 degrees. We plug this one, we get 36 minus 9, that's 27 degrees. In the top one, we get 6 plus 22 minus 1, that's 28 minus 1, that's 27 degrees. Hey, it worked out. So it's saying find the measure of angle RST. So RST is this angle. So what it was asking for was the measure of angle RST, 27 degrees. Okay, I'm going to pause this and go to Zoom. I'll be back. Okay, I'm back. So let's find measure of 1 if it's complementary to angle 2 and 2 is complementary to 3 and, okay, so if measure 2 and 3 are supplementary, they add up to 90. So you go measure of angle 2 plus the measure of angle 3 equals 180. That's the definition of supplementary. So we subtract and we get the measure of angle 2 is 54 degrees. And then it says angle 1 is complementary to angle 2. So that means they add up to 90. So that means measure of angle 1 plus measure of angle 2, which we just found is 54, adds up to 90. That's the very definition of complementary. So we subtract and we get measure of angle 1 equals 36 degrees. Okay, then find y if two lines are perpendicular. Y is in the interior. So we've got xw and xz. Okay, so here's a w and a z and they intersect at x to form a right angle because wx and xz are perpendicular and they both had an x. So that's where they intersect. So y is in the interior of angle WXZ. So y is in the interior somewhere over here. Well, I should do capital Y. It's a point. And then angle WXY, so that's this angle, is 6y minus 3. Sure, I should probably zoom in a little bit here. And YXZ is 4y plus 13. Well, the key there, right, is we have a right angle. That's the very definition of perpendicular. And then it's just saying if we have some point in the middle, then the two parts add up. So we're saying one part of the angle, 6y minus 3, plus the other part of the angle, 4y plus 13, angle addition postulate, adds up to the whole angle. And the whole angle there was 90 degrees. Right? So we could write it with letters, but because of space, I'm just writing out the expressions. Piece plus piece equals the whole 90 degrees. So that means 10y plus 10 equals 90. So that's 10y equals 80. So that means y equals 8. Let's see what it asked for. It just said find y, so we don't need to plug it back in. But we absolutely could just to double check. So I'm going to plug it back in, and the top angle is 48 minus 3, or 45. Whoa, interesting. And the bottom one is 32 plus 13, or 45. Whoa, not only was it in the interior, it was exactly in the middle, forming the angle bisector. So anyways, y is 8. Cool. Okay, find the length of LM if ON is on the bisector. So find the length of LM. So we're looking for the distance from here to here. It says if ON is the bisector. So if ON is the bisector, the definition of a bisector of LM just means it passes through the midpoint. So these two segments are congruent. So this is another 7x minus 1. And it says ln is 3x plus 2. Oh, well, 3x plus 2 over here is the same as this because it's the bisector, so it cuts it in half. So all we do is go 3x plus 2 equals 7x minus 1. So subtracting the 3x's and adding the 1, we get that 4x equals 3, so x equals 3/4. Okay, it said find the length, so let's plug in the 3/4. So on the left, into the 3x plus 2, we get that's 9/4 plus 2. 2 is 8/4, so we get 17/4. And on the right, 3/4 times 7 is 21/4. Minus 1 is 4/4. So that's 17/4. So it did work out. Both halves were 17/4. If we add them together, we're talking about how many fourths we have. So 17 plus 17 is we have 34/4, which we could simplify to be 17 over 2. Or we could have just taken a length of half times 2, and then we could have gone, that's a 2 and a 1, that's 17 halves. So we get 17 halves is the total length of L, right? Find the length of LM. Or we could say that's 8.5 either way. All right, so for 18 and 19, use the coordinate grid. So graph the polygon ABCD. So, okay, let's just make a coordinate plane here in the middle and hope we have enough room. So 1, 2, 3, 4, 1, 2, 3. Here's A. All right. B is at 0, 3. B. Negative 2, 2. So negative 2, 2 is here. C. And D is negative 5, 6, 8. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Well, look at what I can do because I'm on a computer. Oh, so cool. And so now I could do D is negative 1, 2, 3, 4, 5. Wait, 1, 2, 3, 4, 5. I can't count. 1, 2, 3, 4, 5, 6. So then here is D. Okay, so here's the polygon. A, B, C, D. It told us in order what way to connect it. So you have to go in that order. Okay, so 0, 3, negative 2, 2, 4, 3. I was just double checking everything's right. Then name polygon ABCD by its number of sides and classify it as, okay. So it is concave because it has an indent. The indent is right there. Okay, so it has an indent. And then it's not regular. No concave thing is regular. Plus, we can just see the lengths are not the same. Regular means all sides the same and all angles the same. So this is irregular. And then classify it by its number of sides. Well, there's 1, 2, 3, 4 sides. So this is a concave. Order doesn't matter here. Irregular. So I could say either one of those descriptive words first. And then the actual name of the shape is 4 sides, so quadrilateral. Find the perimeter of polygon ABCD. Okay, so for one of these sides, we can just count. If we have a horizontal or vertical line on a coordinate plane, we can just count. So, switching over, this one I could just count as 4. The rest I'm going to have to use the distance formula, but I'm just going to keep using the Pythagorean Theorem because it's so much better. So this one is to find CB, it's a go over 2 and up 1. And then CD is, go back 3. I'm just counting on the graph, back 3 and up 1, 2, 3, 4. I know that's a 3, 4, 5 triangle, Pythagorean theorem, but if you use Pythagorean theorem, you'll find the same thing. And then the last one, AD, is, so this is of length 5 here, and then this one is up 3 and over 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so a 3 and 9. So now we just need to use Pythagorean theorem twice to figure out those missing sides. So 3 squared plus 9 squared equals c squared. That's 9 plus 81. That's 90 equals c squared. So c is root 90. Or if you simplify, then c is square root 9 square root 10 or 3 root 10. You don't need to simplify. You could just stick with square root 90. And then this other one over here is 1 squared plus 2 squared equals c squared. So that's 1 plus 4 equals c squared. So that's 5 equals c squared. So that's root 5. So our side lengths are square root of 5, square root of 90, and 4 and 5. So our total perimeter then, this was the answer for the last question. Our total perimeter then is 4 plus root 5 plus 5 plus, and I'm going to use the simplified 3 root 10, but you could use root 90. Now I could combine like terms, but the only like terms I have is this. So the answer is 9 plus root 5 plus 3 root 10. And there's no way to simplify that, but you could punch that into a calculator and approximate it. Okay, 20. Find the perimeter of regular triangle DEF if DE is that and EF is that. Well, what does regular mean? Regular means all sides are the same and all angles are the same. So that means side DE is the same as side EF, right? It's not just isosceles, it's equilateral. So we know that 2y plus 3 equals 28 minus 3y. So adding the 3y, subtracting the 3, we get 5y equals 25. So y equals 5. But that's not what it was asking. It was saying find the perimeter. So over here we plug it in and we get 10 plus 3. So one side is 13. Double checking. We get 28 minus 15 is 13. So if each side of the triangle is 13, then the perimeter is 3 times 13 or 39. Right? We add up those 3 sides of 13 each. And the last one, suppose a regular quadrilateral and a regular triangle have the same perimeter. Okay, so we got a regular quadrilateral, that's a square, right? All angles the same, all sides the same. And the perimeter is the same as an equilateral triangle. Okay. The sides of the triangle are 3 inches longer than the sides of the quadrilateral. Oh, so here's x, 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 x. Here's x plus 3, x plus 3, x plus 3. Find the lengths of the sides of the quadrilateral and the triangle. Oh, so we just add up the perimeter of the square, that's 4x, and it says they have the same perimeter, so that's the same as 3 times x plus 3. So just perimeter of the square, perimeter of this, and what we knew was each of these sides is 3 longer than the sides of the quadrilateral. So we just solve now. 4x equals 3x plus 9. So we subtract, we get x equals 9. Plugging it in, we get 9, 9, 9, 9 for a perimeter of 36. Over here, we get 12, 12, 12 for a perimeter of 36. It worked out. And so it said, find the lengths of the sides of the quadrilateral. So of the quadrilateral and the triangle, so first it was 9, and then totally separate answer is each of the sides of the triangle were 12. All right, we're on chapter 2. Holy moly, 45 minutes for one chapter. That's crazy. Okay, make a conjecture if you're given both this and this. Well, my conjecture would be that measure of angle A equals measure of angle C. Although it's not much of a conjecture because we actually know that property. It's the transitive property of equality. But conjecture is just an educated guess. So that's my guess. All right, so given that these are parallel and those are parallel, conjecture is that ABCD is a rectangle. Find a counterexample. So if we have ABCD, when could we have AB is parallel to CD and BD is parallel to Oh, sorry, it said A, B, D, C. I got the order wrong. Sorry. So notice that it's at A to B to D to C. So in a loop, A to B to D to C. And so then it says BD is parallel to AC. Well, that's the definition of a parallelogram. So the assumption that it's a rectangle is really saying I assume it's a right angle. So a counterexample would be satisfy these. So we have a parallelogram, but it's not a rectangle. So here's a counterexample. Oh, it just says find a counterexample. So I'll draw my answer here. So here's a counterexample. Now we haven't really investigated. That's going to be in chapter 8 that we really investigate these. But with parallel lines, you know consecutive interior angles add up to 180, but they don't have to both be 90. So here's how about 120 and 60. And over here, same thing, 120 and 60. That's a parallelogram. All the givens are true, and yet it doesn't lead to is a rectangle. So parallelogram. All right, what's the truth value of a statement a square has 4 congruent sides and a rectangle has 4 parallel sides? So if you weren't careful, you'd say super true, but false. And the reason is 4 sides parallel would look like this, right? What it should have said is 2 pairs of opposite parallel sides. But the key is you have 2 pairs, right? It's not 4 lines that are all parallel to each other. These are cool. So it's just saying if all of these are false, what's the truth value of this? So it's saying what's the truth value of false or not false? And then not false, right? Well, let's do this. Well, not false is true and not false is true. And so really this is the same as saying, this is not included, right? But this is false or true, parentheses, and true. Okay, well, false or true, as long as one of them is true, then an or is true, right? Is one of these true? Yes. So that's true and true. And the only way and is true is if both are true. So true and true, yeah, that would be true. Very cool. In a class of 30 students, 22 like watching football, 17 like watching basketball, and 22 make a Venn diagram of these. Oh, cool. So you have a class of 30 students. So here's the whole class of 30 students. All right. 22 like watching football. So here's some that like the football. That's 22. And then 17 like watching basketball. So here's some that like watching basketball. All right. And then there's 12 that like watching both. So 12 like watching both. And how many like football? 22. That means there's 10 that like football but don't like basketball. And then it said there's 17 total like basketball, but only 12 like both. So 17 like it. So you subtract, you get 5 over here. How many of these students do not like to watch either? Well, it said total there were 30. And so if inside here we add those up and we have a total of 27 students, that means there's 3 out here. So that would be it. And so how many of these students do not like to watch either? That would be 3. Okay, write a statement, an elephant is a mammal, and if then. Okay, so an elephant is a mammal, so that's if elefante, then mammal, right? I'm not doing super English grammar here, but that's the idea. If it's an elephant, then it's a mammal. Or if an animal is an elephant, then the animal must be a mammal. You could rephrase it in lots of ways. Okay, write the contrapositive of this statement. So we have if, and then the hypothesis are 2 angles are supplements of the same angle. That's the if part. Okay, then, and then they are congruent. Okay, so the contrapositive would be if, we're talking about 2 angles, so 2 angles are congruent, comma, then, okay, so sorry, so it's the contrapositive, I apologize. So it's saying contrapositive is when you take an A implies B and you negate and flip the order. So it's not B implies not A. So I'm just going to add the word not here. If 2 angles are, and I'm going to slide this over and write a not congruent, then 2 angles are not supplements of the same angle. In other words, if A is not the same as B, then you can't have A plus C equals 180 and B plus C equals 180. That can't be true, right? Because if that was true, we could go, well, that means A plus C equals B plus C. Subtract, that means A equals B, right? So that can't be true. So we go, this is, so not in parentheses this. That's the idea. But you just really put the word not in front and switch the order. Okay. But that's a long one. So this is the answer there. Okay, use the law of detachment to write a valid conclusion. So law of detachment is saying if I have A implies B and I'm given a fact, then for that example, that fact, we know B must be true because it literally slides from A to B. So the swim team has practice on Saturday and Matt person is on the swim team. Then that means swim team has practice Sunday. That means Matt person has practice Saturday. So Matt, that's his examples on the swim team, has practice Sunday. Use the law of syllogism. So syllogism says if A implies B and B implies C, we could combine them to make one big A implies C. So we have if x plus 6 is equal to 10, then x is 4. So that's our A to B. And then we have starting at B, if the x equals 4, then it leads here. So we now know that if x plus 6 equals 10, then we could skip the x equals 4, then x squared equals 16. Okay, that's what law of syllogism does. Just puts two conditionals together. Name the theorem that can be used to state that if AB is congruent to BC and AD is congruent to DB, and holy moly, this is a lot of stuff. Okay, so AD is the same as DB, and BE is the same as EC. Sorry, 2 marks. And AB is the same as BC, okay? Given B is, holy moly. Okay, so it's saying, how could we say all of that if we were given, it's written backwards. So if we were given all that, what lets us say this is true? Well, if we're given words, how do we say facts? We always use the definition. So that's not a theorem, but that's the definition of the midpoint is what we would do. The book calls this the midpoint theorem because they often, they say the definition of a midpoint is that they're equal, and then they use definition of congruent segments to say they're congruent. And so that slight interchange, they call it the midpoint theorem, but I'd be totally okay in class if you just said that's the definition of a midpoint. Okay, I'm going to pause here, go back to Zoom. I will return. Okay, so here we go. I'm jumping into chapter 2. Sorry, I had to jump back to Zoom. Okay, we're going to do some algebraic proofs here. So we start with the given. Great. First step here looks like what we did is we distributed in this 2. So that would be the distributive property of equality. And then after that, the next thing they did is they combined these two on the left. So yeah, addition of like terms or simplify your arithmetic there. And then after that, looks like they added 5 to both sides to get this to be 16 and get rid of that. So that's addition property of equality. And then after that, they subtracted 16. So subtracted the 6x from both sides. And that was subtraction property of equality. And then after that, they divided by -4. So division property of equality. All right. Down here, they started with a given is perpendicular. Then they wrote the other given that it's complementary. Both of those were given. And then we said perpendicular lines meet to form a right angle. That could have also been definition of perpendicular lines, either one. Then it's saying a right angle is 90 degrees. That's the definition of a right angle. How do we know that angle ABC, that's this angle in the picture, plus CBD in the picture adds up to a total of angle ABD? Why, that's the very angle addition postulate. That's piece plus piece equals whole angle. Okay, then we know that angle ABC plus angle CBD equals 90. Well, that was just substituting in that ABD was 90. And we know that angle ABC and CBD are complementary. That's just from the step above down below. And so if they're complementary, that's the very definition of complementary angles. And then going to the next one, this is combining, and it's hard with, I like flowchart proofs, as you know from all of my videos. You can't see where this one comes from, but we have these are complementary and we have these are complementary. Now I would have I would have pulled this given in when we needed it rather than just throwing it out in the middle. And then let's see, putting those together so they're both complementary to the same angle. So we could just algebraically be like, well, if a plus x equals 180, complementary 90, and if b plus x equals 90, we could just say, well, then a plus x equals b plus x. And then subtracting the x, we get a equals b. They're the same as each other. But we did that in a theorem. And so the idea here, I don't remember what the name of this theorem was, but the idea is if two angles complementary to same angle or congruent angles, then two angles are congruent. That was the theorem. So you can always on a proof write out the theorem with a clear if-then. So you're writing out the ifs part and then saying that leads to the then part, right? Or you could say, I'm assuming it's called like the complement theorem or something like that. Okay, for questions 15 and 20, name the definition, property, postulate, or theorem. So points A, C, and E are coplanar. Okay, so through any 3 points exists at least one plane. Or another way to write that is that any 3 points are coplanar. It's if the 3 points are non-collinear, so if they're not in a straight line, they determine there's only exactly one plane that goes through them. But if we don't know whether they're on the same line or not, they could be on the same line or not. So there could be one plane through, many planes, but there's at least one. Okay, and I don't know the name of that definition. It's a postulate, but I don't know which postulate. It's one of the very first like 5 or 6 that we threw out when we said through any 2 points there exists a line. Given a plane, it contains at least 3 points, that sort of thing. Okay, so if AB is congruent to CD, then A plus B equals C plus D, and we add the same thing to both sides. Well, that's kind of 2 steps. First, they use the definition of congruent segments to get this. So first it was definition congruent segments, but then after that they added the same length to both sides. So then that was the addition property of equality after that. If AB is the same as XY, then XY. This is the property that we'd never really use. This is the symmetric property of congruence. We don't use that one that often. So if we have this, then we could distribute the x in. So that's the distributive property of equality. If 2 angles are vertical, then they are congruent. That's the vertical angle theorem that states that. If 1 and 2 are right angles, then they're congruent to each other. We just called that all right angles are congruent. I don't think we had a like title name for that. But that was the way we wrote it in reasons and proofs, right? Because it's easy. You just go definition of right angle. They're both 90, so they're both equal to each other. Definition of congruent angles, they're congruent. So it's only like a 4-step proof or something like that. All right, so bonus, if we have ABD, so this angle right here is 6y plus 2x, and DBC is 5x plus 8, and the measure of ADB is 9x plus 4y minus 1. Ooh, I'm having to write really small here. And CDB is equal to 10y plus 4x minus 1. Oh, I mixed mine up there. This was plus 4y plus 3. So the idea there is we have x's and y's all entangled together. So we need a system of equations here. So we need 2 equations, each with 2 variables. So one equation is these 2 angles add up to 90 because they form a right angle. And then the other one is these 2 add up to 180 because they form a straight line. So I'm going to go from this because I think I had some typos. So ABD and CB and DBC, these 2 add to 90. So over here I'm going to go 6y plus 2x plus 5x plus 8 equals 90. That's 1. I'm going to clean up a little bit. That's 5x plus 6y. No, sorry, 7x plus 6y. And then I'm going to subtract the 8 from both sides. That's equal to 82. Okay, so that's one of our equations. The other one is 9x plus 4y plus 3 on the bottom, plus the angle adjacent to it. It's linear pair angle equals 10 or plus 10y plus 4x minus 1. That all adds up to 180 degrees. So that's how many x's? 13 x's plus how many y's? 14 y's. And then these two add up to a positive 2, but I'm going to subtract that 2 on both sides, and I'm going to get that's equal to 178. So my systems of equation is this and 13x plus 14y equals 178. And so what I can do now is somehow use some canceling to make these cancel out. It doesn't look like elimination here is going to be that clean. These are going to be big numbers, which is a bummer, but whatever, it happens. So let's see, what's the easiest one here? Whatever, let's just do manually. So let's multiply the whole thing by 7, this whole one by negative, oops, I did that backwards, by negative 7, and this whole one by 13. And so what we end up getting is this number of 7 times 30 is 70, that's 91. So we get 91x plus that's 60 and 18. So that's 78y equals whatever 82 times 13 is. And then on the bottom we get negative 9, because this was multiplied by negative 7. So negative 91x. And then this is minus 7 times 14 is 70 and 28. So that's 98y equals, and this is negative 7 times 178. And so when I add those together, these cancel out, and we get a negative 20y equals, and this we're just trying to find x and y. So negative 20y equals, and then I got to work this out, and that's not going to be fun. I'm going to pause this and just do that arithmetic on a calculator. Okay, that was quick. So negative 180. So we divide both sides by negative 20. And we get y equals 9. Whew, those are big numbers to get y equals 9. And then we go back over to one of our equations. I'm going to choose this one because it had smaller numbers. And so plugging that in, I get 7x plus 6 times 9 equals 82. So that's 7x plus 54 equals 82. Subtracting, I get 7x equals 28. So x equals 4. And then we should go back and plug this in just to see what we get here. So I'm going to move these, and or actually I'll do it up top, okay? So we get, this is 8 plus 6 times 9, that's 54, so that was 62. And then this angle over here, that's 20 plus 8, that's 28. And sure enough, those add up to 90. Things are looking good. We plug it into the other one, and I'm going to first time not do it. So we get x equals 4. We get y equals 9. All right. So I'm going to take a break there. I'm going to do this in sections. So we'll do chapter 1 and 2 together as a unit.